Mr. LaBeouf here for the 8th grade Algebra 1 students. We will continue our exploration of quadratic functions. I've indicated the general form, standard form quadratic function up above, and this video is going to focus just on the a. So we're going to let the b and the c each equal 0 so we're not distracted by them, and we're going to consider quadratic functions in this form, y equals ax squared. Now the first thing I want to note about that is that clearly the origin is part of the graph of this function, because if x is 0, the right side will be 0 and y will be 0. In fact, as you will see, the origin is the vertex for each of these quadratic graphs. Therefore, both the y-intercept and the x-intercept are 0. The only place that each of these graphs will cross either axis will be at the origin. So make sure you're clear on that. And there are two things about the value of a that are important. First is the sign of a, and the second is the absolute value of a. Let me just state the rule, each of the rules. It's not very difficult. If a is positive, the parabola, which is the graph of the quadratic function, will open up. And if a is negative, the parabola will open down. The second rule, having to do with the absolute value of a, is this. The greater the absolute value of a, the narrower the parabola is. And the smaller the absolute value of a, the wider the parabola is. At this point, I'd like you to go to desmos.com and take a look at these 6 functions. Maybe do it in this order. Type in y equals x squared. Y equals x squared is what we call the parent function. We sort of consider all of the other quadratic graphs in relation to that parent function. It's the simplest of all the quadratic functions or quadratic graphs. It's a parabola that whose vertex sits right at the origin. And of course, it has points on it like 1, 1 and negative 1, 1, right? 2, 4 and negative 2, 4. You should be able to see that symmetry with points like that. And by the way, what is the value of a in y equals x squared? Well, you should know it's 1. Now what I'd like you to type into Desmos, and you can, maybe if you want to, do all 6 of them at once, if you can keep that straight. If that doesn't drive your eyes crazy, you can see all of them there at one time. Go to a new line on Desmos and type in y equals negative x squared. What is the value of a there? Well, it doesn't appear to be a number in front of the x squared, but of course it's negative 1 because of that minus sign. If we put y equals negative 1x squared, it would be exactly the same as y equals negative x squared. And notice what happened to the parabola. It is the same width as the other parabola, as the parent parabola. It just got flipped down so that it opens down because the a is negative. The vertex of the graph is still at the origin, but it opens down. And the two parabolas are congruent because the absolute value of a is the same. Now try y equals 3x. What you'll notice is you have a much narrower parabola than the parent function. And then if you type in y equals negative 3x squared, it'll be the same parabola as this, congruent to this, but it will be reflected down. It will flip over the x-axis and open down. The absolute value of each of these a's, the 3 and the negative 3, those absolute values are greater than the absolute values over here, which were 1, and so that resulted in a narrower parabola. And the final two to consider are y equals 1/3 x squared. If you type that in, you're going to get a very wide parabola because the absolute value of a is fairly small. It's smaller than the 1. It's much smaller than the 3. So this is going to be a wide parabola. Y equals negative 1/3 x squared. will be congruent to y equals 1/3 x squared, but it flips down and it opens down rather than opening up. So to review the two rules, when a is positive, the parabola will open up. When a is negative, the parabola will open down. When the absolute value of a is big, the parabola will be skinny or narrow. When the absolute value of a is small, the parabola will be wide. That's it. Play around with it for a while until you're very confident with it. And notice up here, we let b equal 0 and c equal 0 for simplicity, but these rules about a all still apply no matter what the b and c's are. So that's it for now. Come to terms with a. Bye-bye.